NASA has developed a number of laser-based systems to measure winds and aerosols in the atmosphere. One of them is called Dawn, the Doppler Aerosol Wind LiDAR, which is pictured right next to me here. And another one is HALO, the High Altitude LiDAR Observatory. The instrument integration process on the DC-8 is very technically complex. One has to ensure that the instruments are fitted appropriately into their viewing ports and that they are very stable and anchored down to the aircraft, and ensuring that all of the cabling and wiring that goes into connecting the computers and other equipment to the actual instrument itself is quite a process that involves a diverse team of technicians and engineers to make happen. This is personally my first flight on a NASA research aircraft. Never before have we been able to fly a system that can measure water vapor, winds, and aerosols all simultaneously on the same aircraft.
Here we have the Doppler Aerosol Wind LiDAR, or Dawn. And as you can see here, we have signals coming in from the laser beams that we are shooting. We are taking about 10 beams per second in multiple different angles. As this laser pulse moves at the speed of light, hits particulates in the atmosphere, or aerosols as we call them. The movement of these particulates causes the light that we shot out to shift a little bit in frequency. We call that the Doppler shift. And we take that Doppler shift and we use that to compute wind profiles through the atmosphere. Back here, we have the High Altitude LiDAR Observatory, or HALO. And so HALO has two primary functions. It measures aerosols and water vapor in the atmosphere. So these two systems, Dawn and HALO, are again shooting lasers, and so we're coming up with kind of a remote sensing estimate of what the winds, water vapor, and aerosols are. But this instrument right here, which is a dropson system, so we take the dropsons, put it in this tube, pull this lever, and it sucks it out of the plane. From this data, we come up with very, very detailed pictures of what the winds are, the water vapor, temperatures are in the atmosphere that we can use to validate these remote sensing estimates of wind and water vapor from the lasers.
Up until now, we only have a finite set of measurements to understand what winds are in the atmosphere. We launch weather balloons, but those only occur at fixed locations. We use satellite data to track cloud and water vapor features along in time, but only at levels where those clouds are located. One of the beauties of Doppler Wind LiDAR is that it allows you to measure winds in what would otherwise be invisible conditions, so cloud-free conditions. We're doing this to understand how accurate these instruments are, and also to understand how we might be able to take these instruments to space someday. With these laser instruments here, we're being able to collect very, very detailed profiles of water vapor, wind, and aerosols that can be used to put into weather forecast models to improve their accuracy.